Hey, it's Kley. Welcome to another video. This is the next progression in my video where I'm going to build a Hifi DIY tube amp. I'm using some PCB layout here. So what I've got in front of you is, on our last episode we talked about the schematic, and what I've really done since then is I've made some very minor changes to like some of the components or some of the choices here, but it's mostly been about getting this layout on this printed circuit board ready to go. So in Eagle, once you have finalized your schematic, then you have the opportunity to create a board. Now this is kind of the finished product. When you start, you have this rectangle that's a different shape, and then you have all these individual components which are off on the side, and you have to move them onto your board and arrange them in such a way that is logical for your project. And then you also have to make traces. So those are those little red and blue lines running all over the place. And I wanted to talk a little bit about some of the choices that I made when I was setting out the layout of this amplifier. Let's talk about the location of components, because I think that kind of helps you get started. I would say there's a couple of major things that I wanted to highlight. So first of all, I've got my tubes here kind of in the center, running in this horizontal linear fashion. Our rectifier is over here on the right, the two 6v6s are here kind of in the middle, and then the preamp 12AU7 driver is over here. Now the main reason why I laid out my tubes in this fashion is I'm kind of trying to apply some of the lessons that I've learned in tube amp making to PCB. So for example, you typically want to have your small signal preamp stages as far away from these larger power supply wires as possible. So for example, these two red pads here, that's taking in the high voltage B plus from the output transformer to be rectified. Over here, we've got 5-volt filament windings. Over here, we've got this big blue is our big ground bus that's grounding a lot of these larger powered components. And then down here on this bottom side is where we've got our big high B plus voltage step down circuit to filter out some of those high voltage lines that are feeding the plates of these tubes. So I'm trying to keep those larger signals as far away from over here where we've got the input, and then we've also got our two volume controls, and we've got these little resistors and capacitors here all governing the bias and the operation of these two triodes in this 12AU7. So trying to keep as much distance and space as possible from the input from the power supply. Second, I tried to use more or less a specific grounding scheme. So like with a pedal, what you would typically do is you would draw a polygon and you have the entire back plate of the PCB be kind of a ground fill plane type thing. And with this type of amp, I did not want to do that because we do have some pretty massive differences in the signals that are being grounded. You know, for example, at these initial stages, we've got these big B plus capacitors that need to be grounded out, and they're filtering out the large voltage direct current. You know, contrast that with something like this input resistor. You know, that is doing a much different job, and you don't want to get those ground planes interfering with one another. So I've kind of got a ground plane up here, help covering the input, another ground plane down here covering this input, and then I run kind of in a star fashion down the middle of the board to this point here, which will ground out to a lug that is bolted to the chassis. So I've got kind of a star ground system where, again, the ground flow is more or less contained to where it needs to be, and the preamp stuff again is kind of staying out of the way compared to the power amp stuff. And then second, or third, I guess, I'm using somewhat large traces, meaning the physical size of this pad of wire. I guess it's not really wire. I think it's a copper trace. That is actually fairly significantly large. If you, just for comparison, let's say if we kind of get rid of this one right here, let's just take a look and see for a second. So what we've got there is more of like the default width, and I'm using a much significantly wider I'm more at like 50. So, the reason why I did that is because, again, with a tube amp like this, I think we are dealing with a little bit of a hotter signal. And so I do believe it is going to be helpful for me to be using a little bit of a thicker trace. And really with this PCB, you can see there's a good amount of dead space. I'm not really packing the components super tight to try to minimize space as much as possible. I'm being a little bit gratuitous because really with this PCB project, I'm not sticking this in like a very small enclosure, right? I'm going to be sticking it into a chassis that's going to have plenty of room. And so my space is not really an issue with this kind of a build, but really using the PCB is more of kind of a proof of concept to see how it works for my kind of workflow. But ultimately, I think giving yourself a little bit more room here in space is hopefully going to be helpful. And then lastly, I wanted to kind of just briefly talk through the signal flow of the audio path, right? So how am I laying out my signal flow? That was something I really tried to think about as I move forward. And I kind of got to a place where I was really tweaking a lot of small minor things, and it felt like at some point you just got to be done and you just got to go for it. So the first tip I would give is for situations like this, you want to try to avoid 90-degree angles as much as possible, and you want to have 45-degree angles. And so all these little breaks you can see I've got here are typically running at 45-degree angles. And I think that helps to make sure your traces are as reliable and robust as possible, and you don't have any problems with them down in the future. So next, we've got our input right here. Now, these are the traces for the volume control. Now, I may at some point choose to not use an input volume. We'll see kind of how we decide to do that, but really with my setup, I'm running out of a computer into an audio interface, and my audio interface has a monitor volume control. So I may end up just using that, and if that's the case, then I would change my inputs to be right here at this second stage of the potentiometer. But if I wanted to use a dual gang pod, I could, and I just would run wires from where that pod is mounted on the chassis to these 3 or 6 really traces. But then we come out of the volume control into here. This R16 is the 1 meg grounding resistor, and then this is kind of, I believe, our grid stopping resistor going into the grid of the 12AU7. Now, I believe our cathode is coming out here. Here's our cathode bias resistor and cathode bypass capacitor. Now, this also may be something I'll experiment with, is putting the cathode bypass capacitor on a switch, or even just leaving it out entirely if I feel like I've got a sufficient amount of gain. What I will probably do is my initial wire up, I will leave it out, and then we'll kind of see how, if we've got good signal to noise ratio, and leaving that open as an option to add the cathode bypass cap if I want more gain. But I've got a feeling I'm going to have plenty. So then I believe our plate is coming out here, and that's where we kind of split here. And on one half we have this is our 100K plate resistor coming in from our B+. So this is kind of where I'm trying to, again, keep the signal divided. But then on this other side, we go up here to our, now this is interesting because this resistor is actually our negative feedback resistor coming out from the plates of the power tube. But then we go through this C1, this is our coupling cap, and then we go through a couple more components preparing it for the grid, which is here on pin 5. So a lot of my audio signal is really kind of right in here in this situation. And then again, we're keeping that kind of away from the power supply down here. Now, to some extent, I had to do it a little differently from this other tryout. Again, we come in here through the volume control, grounding resistor, and then this path here brings us to the grid. Now, this was something where, if you could see up until now, all of these connections, except for maybe this one, have been with red wires. So that's another thing I'm trying to do, is I'm trying to keep most of my signal flow on the top of the board and then keep as much of my grounding on the bottom of the board as possible. But in some situations, I was not really able to do that, and it was just kind of impractical. So I did run into the grid here. Cathodes come down here. And our plate comes out here. We've got our plate resistor bringing our B plus in, and then we do have a coupling cap here. Now, in hindsight, again, this might have been something that I could have done a little bit differently, but really the problem is that I have to get all the way over here to pin 5, which is our input grid on this other 6v6. And I didn't really want to route all this up above, so I did just kind of choose to come down here, and this is really the only piece of the circuit that I felt like is needing to kind of come down towards the power supply. So if at some point I get problems with that, I can probably try to find another solution, but for now I think we're going to be okay there. So coming out of this coupling cap, running into some of these resistors, and then we get into this other 6v6. Our 6v6s will have their outputs kind of up here on this top middle portion. So again, kind of isolated from everything else. Got our two outputs, or I guess our outputs to our output transformers from pins 3, which is our plate. And we also have our ultralinear switch. The wires going to the ultralinear switch will be here. So overall, pretty solid and straightforward layout, which I was pretty happy with. Like I said, I did a lot of iterations on it, and ultimately I'm sure there are little things about it that I could probably improve, but for now, I'm pretty happy with this. I think maybe the only other thing to mention is I did have kind of a heck of a time with this B plus step-down circuit here, getting the correct sizing for the resistors and the capacitors. I'm still not even 100% sure that this is, in fact, the correct sizing, but it's what I've got, and it's what I'm going to stick with. And that's just kind of some of the prototyping stuff where, ultimately, the best practice there is just to physically get some of those parts and measure them out and make sure that if you look at this component, you can actually if you pull it up in here, you can actually see these resistors. You can actually tell or see how big they are. Right here, you've got this 5 millimeter. So this would be a pretty small little resistor, and you definitely need something a little bit bigger there to make sure that we're on the right track. But that's just kind of a part of this that I had to go and find some larger sized parts to fit in this because my library didn't quite accommodate it super easily. So anyways, this is my PCB layout. I hope that you guys enjoyed this. If you have any inputs or suggestions, please leave it down in the comment section below. Hope you found this helpful. And if you have any questions, let me know. If not, I'll see you guys again soon. Thanks for watching. Bye.